Welcome back to R for Economics. In this video, we'll be talking about the Garch model. So there are two packages for Garch, the F-Garch and the RU-Garch. Both are very similar. The F-Garch is more of a general or the general form of the Garch model, and RU-Garch allows for more intricate models, which we'll see. We're also going to bring in some data using the quant mod, and we're also going to use the forecast mod in order to do some post-regression analysis, some predictions. Okay, so in this, we're just going to simulate a Garch 1-1 series with these parameters with 2,000 observations. So we can see our series here, and there's going to be some Garch tendencies to it. And then if we run Garch fit, which is from the F-Garch package, we can see that we can get the model itself, and we see that alpha is close to the 0.1 and beta is close to the 0.8. And then we've got the mu and omegas as well. Omega is the unconditional variance of this series. So we're able to quickly estimate a Garch model, and if we wanted to do a more elaborate Garch model, we could easily do that as well, and it gives us 2 alphas rather than 1. Now, let's bring in some data. So we're going to bring in the SP plus symbol, and we can plot the adjusted, and we can see what the data looks like. And this is the most recent observations at the time of recording this video. So then we can plot returns, and we can see that there's clusters here, a cluster here, and a cluster towards the more recent times, which says that this is there seems to be some Garch tendencies or some conditional variance. Okay, we can look at the ACF and the PACF, and we see that there might be some kind of reaction to the lag. So maybe an ARMA might actually fit this. If we run the auto ARIMA, we can see that it actually wants an AR4 MA2 model. And if we wanted to look at the residuals, we could. Now, we're going to test for arch effects, and as we can see, the p-value is really small, which means that there are actually arch effects occurring. So now let's fit a Garch model. Now we'll just go to a simple ARMA 1-1 and a Garch. Got a warning, but we can see that the Garch fit had an AR and an MA and the omega for the variance and covariance. And we can see that the Garch part of the model fits quite well, while the the ARMA is not as strong. And then there's a series of tests that you could look at. We can also predict, so we can get a 20-day prediction of the mean, and also the error on the mean, but also the standard deviation. So this is the variance of the errors. So we can get both things. Now, if we run this with no ARMA, because we just found out that it didn't fit very well, and we can see that our Garch parameters are fairly strong. And if we plot the predicted, we can see what's happening to the variance over this time, that it's getting larger and it's trying to stabilize over the 20 periods. Now, with the RU-Garch package, we can actually run different types. So the integrated Garch, it forces the Garch parameters to be integrated of order 1. So we can run that, and we can look at the fit of this. So we set up our model, then we run our model, and then we can look at the summary. We can see that it's a Garch, and if we fit iGarch, we can look at a number of statistics. We can see the alpha and the beta, and we can get the standard errors for each of these robust standard errors. The AIC, BIC, and so on. And we can go through many analyses of the results. We can also do a prediction of what the variance is. The sigma is what we're interested in. And we can also run a Garchian mean, which means that a Garch model has a mean effect in it, is included in the model. So it has the Garch in the mean. So even if you had an ARMA, it would try to include that in as well. Last one we'll look at is the asymmetric power. And here we can see that the model runs, and this gamma is indicating how much the relationship is asymmetric and how much the variance is asymmetric when looking at that. Looking at the series and the errors. Okay, so that's a quick primer on the Garch model, and we'll see you in the next video.